I've had this lead light out in my workshop for quite a few years. It's seen a lot of work, as you can see. I've always put it on charge straight afterwards to make sure that the batteries are charged. But notice what happens when we turn it on nowadays. Okay, we've got the light, yeah, not too bad, but oops, there it goes. And notice the little charge light comes on. This has recently been on charge. As you can see, it's just coming and going. What's the issue? Let's have a look. At the moment I've got the battery pack back probed, as you can see. We're getting a reading of 7.25 volts. But what does the battery pack say the voltage rating should be? Let's have a look. If you have a look, you can see that the rating is 7.2 volts. And you're saying, what's wrong with this guy? Why would he replace the battery pack when it's clearly within the 7.2 volt range? Well, there's one thing that I haven't done when I checked for the voltage at the battery, and that's put it under load. Taking exactly the same reading at the battery, but this time putting it under load. So I'm going to turn the light on and see what happens. Can you see it draining away really quickly? At the moment we're down to, well, I can't keep up with it. It's 6.2, 6.1, and if we were to turn it over, you would see that the lights are fading very quickly. And of course the low charge red light is on, as you can see, and all the LEDs are really dull, and that's lightning in the background. So we're down to getting to 5.5 at this point in time, and of course that is why you need to do things under load, because otherwise you won't get a correct reading. This battery pack is past its use by date. It's seen better days, and by replacing it with a better battery pack, in fact I'm going to once again supersize it, and that way we can get a lead light that will last a longer amount of time before we have to charge it. Okay, down to 5 already. It's going to cruise down to 4 volts shortly. There we go, 4 volts. Miles too low for a lead light, and in fact you can see all the lights have disappeared totally, only left with our charge light, our red charge light. So, time to replace the battery pack. You'll have to excuse all the background noise. It's actually pouring down outside with lightning and thunder, but we'll continue on. The lead light is actually quite basic in construction, quite easy to pull apart. It's only a matter of a series of screws that hold the back cover on. Back cover comes off. The lighting bank goes in there like that. The little charging section is over here. This is the charging and current sensing area to find out when it's actually going too low to be usable. The battery pack actually just goes straight in the handle there. That's slipped straight in there like that. And then the end cap, which then plugs into the board here. Our charging one over, our battery one over this side, and our charging one over this side. So the main problem that we're having now is the battery pack, as I mentioned. The good part about this battery pack is that all the details are on the front there. We can see it's a nickel metal hydrate battery pack. We can see that the coding is 2/3A, that's the one that I need to look at. The milliamp hour rating is 1100, and once it's in series, all the batteries put together, it comes to a total of 7.2 volts. We can see it's been done in, or the battery pack was assembled in 2007, so it's actually done quite well considering the amount of use that I put it through. So to make up a battery pack, it's actually a bank of batteries that are put into series to add up to 7.2 volts. I went through that one in the vacuum cleaner that I replaced the batteries in to show you what series means. So how do we get one of these little suckers at 1.2 volts to add up to 7.2 volts? Let me explain. Our trusty whiteboard, if we add up all our individual batteries at 1.2 volts, we'll find that they add up to 7.2. I'll show you what I mean. So 1.2 plus 1.2 is equal to 2.4. And then add another 1.2 is 3.6. And then add another one, we've got 4.8. Add another one, we end up with 6. And then we add another one and we end up with 7.2. So 7.2 is the battery pack voltage that we're after. When I did my vacuum cleaner battery replacement one, I soldered directly onto the batteries, the top and positive and negative, of course, and it was mentioned to me that that's probably not the best method, but these are available. The ones, they actually have little tabs attached to them, as you can see, and the beauty of that, of course, is they're already spot welded onto the battery, and then you can just solder onto the tabs. Then there's less heat transfer. I've had no trouble with my vacuum cleaner whatsoever. In fact, it's doing very, very well. But I appreciate the comment of the person that put it up for me, and I will take their advice of using a tab style battery. So they are available now, and they're pretty much the same price as the others. These are the 2/3A style, but notice I'm putting in. So after slicing through the side here the plastic covering with a knife, you should be able to just peel that off, and as you can see, it's just made up of a series of batteries there, with an end cover either side, which is nice, and you can see it's been put into series. In fact, they've used the same style of battery as what I have, so that's really good to copy. There's no temperature sense in this particular style of battery pack, so it's going to be fairly basic repair. But as you can see here, they're joined as individual batteries. They're joined in the middle across here. So obviously I'm going to have to get my tabs there, bend them into one another to build a single pack, and then of course do a series together. First things first, with the new batteries, they're clearly identified as positive and negative. Also, one thing to keep in mind, you note that one side has actually got an insulator on it. It's just easily pulled off. In theory, there we go. But just make sure you pull that off before you do any soldering, otherwise you're going to make a mess. Of course, because these are in series, we have to add them together in a certain pattern. And if we go here, we have a positive, as mentioned before, and a negative. So we actually have to join those two together. That will give us our series connection. Because I had a bad experience with batteries bought from overseas and they were flat, they were past their shelf life, before I did this or started this project, I've checked every single individual battery and made sure that they were the official 1.2 volts that they were meant to be. As you can see, 1.28, which is awesome. I've checked every single one, as I said, and they're all pretty much the same. So what I've decided to do is just bend that tab over like that, so it's nice and flat, and exactly the same with my negative one, which would be that one. And then that way, all I'm going to do is I can fold them apart. I'll just solder those two pieces together, and that way I'll know I'll have a good connection. What I have done is just put on some flux on top of this, just to make sure that it's going to have a really good connection, and just a tiny bit of solder onto those tabs. And then when they join together, they should, you don't have to have too much heat in there, which is a good thing about these tabs. You don't overheat the battery at all. So all I have to do now is bend my tab over like that, line it up with that tab, and just solder the two together. See the tabs soldered together nicely, no problems there, and all I have to do is fold it to fit into the pack. Now that I've got all my little battery assemblies together, my two packs, I need to now assemble it into the main pack. Now they are a little bit difficult to hold, so I've used some insulation tape just to hold them in place, but I fortunately happen to have a vise that has plastic jaws here. That'll be excellent. So I'll just join these little two pieces together, solder them together, then I can continue on to complete the battery pack. Slowly getting my battery pack together. All I have to do is, obviously this one is a positive and this is a negative, joining that one down to that next, and then this will be my, if that's positive, that's negative, that will be a positive out there, and the other end will be a negative, which in turn I'll have to solder onto the wiring of what my original pack was. Before going any further, it's pretty crucial that you make sure that you've connected your battery up correctly in series and that you get your 7.2 volts total. So let's just, I've got it connected up as you can see. We'll just put it to DC volts and see what we read. Okay, 7.5, 7.6, which is excellent. So that is hooked up correctly. All I've got to do is encase it in some sort of heat shrink perhaps, and then put it back into my light and enjoy the brightness of my new light. So I didn't have any heat shrink big enough, so I've just reused the original casing. I just cut it down here originally, so I've just put some tape right around it to hold it in place, and then I've used some hot glue to put my end caps on so that it'll be fully insulated. So now it's time to put it back together. We should have a really bright light. Is that bright? Hey, is it? Okay, awesome. So now I just need to pop it all back together and put it on charge maybe overnight, although it seems to have plenty of power at the moment, which is awesome. So I'll pop him back together. I'd call that a fix, wouldn't you? We've gone from a little battery pack that needed to be replaced into an efficient working lead light once again. So done and dusted. I can put that on the out pile and stick it back in my workshop for regular use. I hope you've learned something from this video. I've enjoyed making it, and I've learned something too about using those extra little tabs that have been pre-welded onto the battery. It makes it a lot easier to do the soldering job. If you haven't already, guys, please subscribe to my channel, give it a thumbs up, feel free to comment down below. So until next time, this is MiracleMAX. Catch you later.